Hello everyone, my name is Priyansi Bolda. My ID number is 22CS012. Today I am gonna present a topic about multi-core and many-core microprocessor and what is the difference between this processor. So let's start with the introduction parts and contents parts. In this presentation, I have to conclude with these many topics like introduction, architecture overview, parallelism and workload types, memory hierarchy and interconnects, real-world application and use cases, challenges, limitations, future trends, developments, and last conclusion. So first part of this is a introduction. Like multi-core and many-core microprocessor represent two significant milestones in this journey, each with its unique set of advantages and trade-offs. Like multi-core and many-core microprocessor are used in so many processes and devices like that. Uh, in this comparative analysis, we delved into the intricacies of multi-core and many-core microprocessors, exploring their fundamentals, differences, applications, performance characteristics, and the applications they have to on the world of computing. The architecture overview of these both of these microprocessors are like that. In a multi-core microprocessor, there is a shared resources, programming models, and there are so many benefits of this processor. And in many-core microprocessor, there is a specialization programming model in this also microprocessor and these benefits also. Parallelism. What is parallelism? Parallelism is all about the this both of the microprocessor, multi-core microprocessor. In this microprocessor, there are multiple CPUs cores on the single chip. Like on a single chip, there are so many CPUs. Each core can execute instruction independently and concurrently. Parallelism in multi-core microprocessor is typically achieved through the task level parallelism, where the different tasks or threads are assigned to different score or execution. In a multi-core microprocessor, it is designed with a significantly higher number of cores. Like that, there are infinitely cores like that, often ranging from the dozens or thousands or hundreds of cores. Medical microprocessors are optimized for a fine-grained parallelism and are commonly used for the highly parallel workloads such as scientific simulations and artificial intelligence and data analysis for them. Workloads types. There are four types of workloads. Like first is a task parallelism and second is a data parallelism. So first is task parallelism. In these workloads, it involves splitting a task into smaller subtasks that can be executed concurrently. Each core in a multi-core and many-core microprocessors can handle a different subtask, allowing for a efficiently execution of multiple tasks simultaneously. This is common in the multiple applications like the web servers and where the multiple clients requests are processed concurrently. And the second workload is data parallelism. In this parallelism, focuses on the parallelizing operations on large data sets that can involve dividing the data into the smaller chunks and processing these chunks into the parallel. This is used in the application like multimedia processing, where is the same operation is performed in the multiple data elements simultaneously. So the next workload types is about pipeline parallelism and the other is thread level parallelism. The first we can show that the pipeline parallelism. What is the pipeline parallelism? Is it achieved by the breaking down a task into the stages and each stages is executed parallelly by the different scores or pipeline stages. It is common scenario like that instruction processing in CPUs where each stage is like fetching, decoding, and executing is executed in the parallel to improve throughput. Other workload is thread level parallelism. Thread level parallelism involves running multiple threads or the processes concurrently on the different cores. This is particularly useful in the applications where the multiple independent threads can be executed in parallel, such as in the multi-thread gaming or videos or in the user servers. And the other part is memory hierarchy, यानी कि memory unit. In this part, the top of the element is always register. In the in the below level there is a cache memory. In the below level there is a main memory, and in the below level there is a magnetic disk and magnetic taps. Whenever we go in this chart above side, there is a costly. There is a um, there is cost is dependently less, and the other side, the downside, there is a cost is dependently high. And the other side, there is a in the top side there is a speed of the memory is very low, and the downside there is a speed of the memory is very high. Interconnects. There are three interconnects in this processor, multi-core and many-core. First is the on-chip interconnection, second is memory controller interconnection, and the third is off-chip interconnection. On-chip, off-chip or memory controller, there are three types of interconnections. Then after we will discuss about real world applications. So the first application of the real world is that scientific computing. Uh, in this world, like that, in this scenario, there are most significant and most simulation types like significant scientific computation is used. First topic is about simulation and modeling. So multi-core and many-core processors are crucial for simulating complex systems such as climate models હોય કે પછી fluid dynamics હોય કે nuclear simulation હોય. ત્યાર પછી molecular modeling બી હોય છે. In a biopharmaceutical and drugs discovery, processors with multiple cores are used to simulate molecular interaction and the protein folding and the drugs binding, like that. Higher performance computing यानी कि HPC. In this applications, supercomputing या many core microprocessors power some of the world's most powerful supercomputer used for a wide range of scientific research, including weather forecasting, nuclear simulations, and the astrophysics. In a parallel algorithms, HPC यानी कि high performance computing system છે in really on the parallel algorithms to solve the complex problems efficiently. And the next topic of the application is about the network security and cryptography. So in this network security and cryptography, encryption and decryption, there is the important topic. Multiple microprocessors are used for the fast encryption or decryption of data and for running cryptographic algorithms to the secure communication, instruction detection, a real-time analysis of network traffic for detecting and preventing security branches benefits from the parallel processing. And the other application is about aerospace and defense. Like that, aerospace and defense. In the topic there are in a flight simulation હોય કે પછી radar signal processing હોય કે પછી electronic warfare application હોય, એ બધામાં પણ આ મલ્ટીકોર અને મેનીકોર માઇક્રોપ્રોસેસર યુઝ થાય છે. લાઈક ફ્લાઇટ સિમ્યુલેશન હોય તો એરોસ્પેસ એપ્લિકેશન યુઝ મલ્ટીકોર માઇક્રોપ્રોસેસર ફોર ફ્લાઇટ સિમ્યુલેશન એન્ડ ટ્રેનિંગ. એટલે કે એરોસ્પેસમાં મલ્ટીકોર માઇક્રોપ્રોસેસર યુઝ થાય છે. જ્યારે રડાર અને સિગ્નલ પ્રોસેસિંગ હોય તો એમાં મેનીકોર માઇક્રોપ્રોસેસર યુઝ થાય છે. ત્યાર પછી છે કોમ્પ્યુટર ગ્રાફિક્સ એન્ડ રેન્ડરિંગ. સો ઇન ધીસ ટોપિક્સ 3D ગ્રાફિક્સ યાની કે GPU with multiple cores are extensively used in the gaming, film production, and computer-aided ડિઝાઇન યાની કે CAD સોફ્ટવેર છે, પછી રેન્ડરિંગ, રિયલિસ્ટિક 3D ગ્રાફિક્સ એન્ડ એનિમેશન્સ. લાઈક એનિમેશન્સમાં ગ્રાફિક્સના અને ગેમિંગના જે બધા સોફ્ટવેર હોય તેમાં આ 3D ગ્રાફિક્સમાં કોમ્પ્યુટર ગ્રાફિક્સ અને રેન્ડરિંગમાં પણ મલ્ટીકોર અને મેનિકોર યુઝ થાય છે. ત્યાર પછી છે રે ટ્રેસિંગ. રે ટ્રેસિંગ યાની કે તે એની રિયલ ટાઈમ એપ્લિકેશન છે ટ્રેસિંગ ફોર રેન્ડરિંગ photorealistic graphics benefits for the parallel processing powers of many GPUs. ત્યાર પછી છે મેડિકલ ઇમેજિંગ એટલે કે મેડિકલ ઇમેજ પ્રોસેસિંગ. Multi-core processors accelerate the processing of medical images for diagnostic, surgery planning, and image-guided intervention. Like જે સર્જરી પ્લાનિંગ હોય પછી ડાયગ્નોસ્ટિક હોય ઇમેજીસ ક્રિએટિંગ કરવાની હોય એ બધાના જે સોફ્ટવેર હોય તેની અંદર જે હાર્ડવેર હોય એની અંદર જે માઇક્રો પ્રોસેસર્સ યુઝ થાય છે તેમાં મલ્ટીકોર અને મેનિકોર હોઈ શકે. ત્યાર પછી છે જીઓમિક એનાલિસિસ. Bioinformatics applications that analyze DNA sequence and genomics data that can benefit from parallel processing. Like જો DNA ની સિક્વન્સ છે અને જે જીઓનોમિક્સ છે એના ડેટા કલેક્ટ કરવા માટે પણ મલ્ટીકોર અને મેનિકોર માઇક્રોપ્રોસેસર્સ યુઝ થાય છે. Future trends and developments. So future trends and developments in this topic. There are so many future trends and development in these microprocessors like that increasing core counts. આપણે કોર્સના કોર જે કોર સિસ્ટમ ચાલે છે કોર i5 i7 i9 એ રીતે કોર કાઉન્ટ વધારીને પણ તેનું ડેવલપમેન્ટ વધારી શકે અને ફ્યુચરમાં તેનો ટ્રેન્ડ પણ વધી શકે છે. ત્યાર પછી છે હિટ્રોજીનિયસ આર્કિટેક્ચર યાની કે તેનું આર્કિટેક્ચર છે તેને થોડું કોમ્પ્લેક્સ બનાવીને એના થોડા વધારે યુઝિસ વધારીને પણ એને યુઝમાં લઈ શકાય. ત્યાર પછી છે 3D સ્કેચિંગ એન્ડ પેકેજિંગ યાની કે જે 3D મોડેલિંગ એન્ડ ગેમિંગ એન્ડ CAD સોફ્ટવેર ને એવું બધું હોય તેમાં થોડુંક ઇમ્પ્રુવમેન્ટ કરીને પણ તેનું ડેવલપમેન્ટ કરી શકાય. ત્યાર પછી છે સોફ્ટવેર ઇકોસિસ્ટમ્સ ડેવલપમેન્ટ યાની કે કોઈ પણ ઇકોસિસ્ટમ્સના સોફ્ટવેર ક્રિએટ કરીને પછી એના હાર્ડવેરમાં આ બધા માઇક્રોપ્રોસેસરનો યુઝ કરી શકાય. ત્યાર પછી છે એજ કોમ્પ્યુટિંગ લાઈક ધેટ આ એજ કોમ્પ્યુટિંગમાં પણ અત્યારે ખૂબ જ વધારે મલ્ટીકોર અને મેનિકોરનો યુઝ થઈ રહ્યો છે. સ્પેશિયલાઇઝ્ડ એક્સેલરેટર એન્ડ સિક્યુરિટી ફીચર જ્યારે આ માઇક્રોપ્રોસેસરનો યુઝ કરીને અમુક એવા ડિવાઇસીસ બનાવી શકાય જે સિક્યુરિટી માટે યુઝ થતા હોય મોસ્ટલી. હવે આ માઇક્રોપ્રોસેસરની લિમિટેશન્સ શું છે તો પહેલું છે ઇવોલ્વિંગ ટર્મિનોલોજી યાની કે એની ટર્મિનોલોજી એમાં ઇવોલ્વ થાય છે. પછી છે એપ્લિકેશન સ્પેસિફિક ડિફરન્સીસ એટલે કે અમુક માઇક્રોપ્રોસેસર હોય જે પ્રોપરલી આ એપ્લિકેશન્સ માટે જ યુઝ થતા હોય બીજી એપ્લિકેશન્સ માટે યુઝ ના થતા હોય. ત્યાર પછી એની કોમ્પ્લેક્સિટી યાની કે આ માઇક્રોપ્રોસેસરની કોમ્પ્લેક્સિટી બહુ હાઈ હોય છે જેથી એને સમજવું બહુ મુશ્કેલ થઈ જાય છે બધા માટે. ત્યાર પછી છે કોસ્ટ કન્સિડરેશન. આની કોસ્ટ પણ બહુ હાઈ હોય છે. ઇકોસિસ્ટમ્સ એન્ડ સોફ્ટવેર સપોર્ટ્સ એના સોફ્ટવેર પણ અમુક સપોર્ટ ના પણ કરતા હોય. ત્યાર પછી છે થર્મલ મેનેજમેન્ટ, સિક્યુરિટી કન્સિડરેશન, power consumption and benchmark sensitivity. The other topic is about use cases. In the use cases, first topic is about general purpose computing. So the multi-core and many-core processors like that commonly used in the laptop, desktop servers for everyday computing tasks including web browsing, office applications, multimedia processing. Many-core microprocessors find applications in the high-performance computing like HPC clusters and the supercomputers for running complex simulations and scientific calculations and data analysis. So the second use cases is about gaming. Everyone know that in gaming there are so many gaming and this is software, AI and simulations and graphics ને so many આ બધા જ ફિલ્ડમાં આ બધા માઇક્રોપ્રોસેસર યુઝ થતા હોય છે. તો મલ્ટીકોર માઇક્રોપ્રોસેસર છે જે એસેન્શિયલ છે ફોર મોડર્ન ગેમિંગ સિસ્ટમ હોય કે એઝ ધે ઇનેબલ ગેમ્સ ટુ ટેક એડવાન્ટેજીસ ઓફ પેરેલલ પ્રોસેસિંગ ફોર improved graphics, physical simulations and artificial intelligence. Many-core microprocessors are becoming more common in gaming consoles and high-end gaming PCs to deliver immersive gaming experience with realistic graphics and physics. And the third applications use cases is about mobile devices. Many multiple microprocessors are used in the smartphones, tablets to provide smooth multitasking, faster acknowledging times, and improve energy efficiently. Many got GPUs and graphics processing units in mobile device enhance gaming and multimedia performance. So the first use case is about data centers. So the multiple microprocessors, power cloud computing infrastructures, and like the virtual machines and handle diverse workloads efficiently. Many microprocessors are used in the data center for multitasking, such as big data analysis, machine learning, and deep learning, inference, and network and communications. Like the multi-core microprocessor are used in the network appliance, routers, and switches to process network packets, manage traffic, and ensure low latency communication. On the other hand, many core microprocessors are implementing software-defined networking (SDN) and the network function virtualization in the environment for high-speed packages for processing. In the embedded system, multiple microprocessors are utilizing the embedded systems such as automotive systems like the industrial control system and the robotics and to handle multiple tasks simultaneously and responding to real-time demands. In a medical microprocessor, they are used in the advanced driver assistance system, यानी कि ADAS and automation vehicles to the process centers data and make critical decisions. The seventh use case is about scientific and research computing. A multi-core and many-core microprocessor are vital roles for the scientific simulations હોય કે પછી molecular modeling હોય, weather forecasting હોય, computation chemistry હોય, and they involves highly parallel computations. Many core microprocessors are used in the scientific supercomputer to tackle complex simulation for solving large-scale problems including astrophysics હોય, climate change modeling હોય કે પછી genomics હોય. ત્યાર પછી next છે digital content creation. In a multi-core and many-core microprocessor are used in the modeling, 3D modeling, video editing, animation, graphics design, accelerating rendering and processing tasks. Visual effects studios for the faster movies rendering and high quality animation products. And the last is about cryptocurrency mining. Like that in a blockchain we can use a cryptocurrency like Bitcoin and Ethereum. In this software and hardware we can use many microprocessors are commonly used in the cryptocurrency mining rings performs analytic calculations required for proof of work mining algorithm like those building Bitcoin and Ethereum. So thank you guys. From this video, we can we can make information about multi-core and many-core microprocessor, like what is that architecture and what is the use cases, what is the limitation, what is the future trends and uh, developments. We can how can we develop the other ideas and other complexity about these microprocessors like that. So thank you.